Here is an easy way of thinking about this problem. Let's look first, or begin with the best that the monopolist can do, or the best solution for monopolists, given that only type 1 buys in equilibrium. So remember that type 1 looks like this. The first unit, the second unit has a value of 20. The second unit has a value of 15. And every additional unit has a value of 0. Okay? Now I claim that in this particular case, the monopolist can get the full surplus, the full social surplus, with setting a P1, a price of 1 equals to 20, a price of 2 equals to 15, and a Q bar equals 1. And in this case, it gets a producer surplus equal to the social surplus equals to 100 times 35, which is $3,500. Now, it's easy to see why this is the case. This is a price schedule that says you have to buy like this, the first unit at this price, after that at the lower price. The consumer is indifferent between buying nothing and buying the 2 units, and the producer gets all of the surplus. Now, this is something that the consumer can do. Now, if there is a better solution, it has to be the case that it involves also extracting surplus from the other consumer and a higher profit than this. So now let's look at the best solution for monopolies given that type 2 buys something. And there are 2 cases that we want to look at. So in case 1, the other person just buy 1 unit, type 2. And in the other case, type 2 buys both units. Okay? Now, let's see what happens if the consumer, in the best solution for the monopolist, in which the other consumer only buys 1 unit. And to remind you, this was type 2. The prices, the benefits for type 1 were at 10 and at 5, 1, 2, and then 0, 0, 0, 0. Okay, now clearly the goal of the monopolist is to keep this price P1 as high as possible to extract also as much revenue from type 1, sorry, this is type 1 and this is type 2, as possible. The best they can do then is set P1 equals 10. That leads type 2 to buy 1 unit, but not the second unit, and it still extracts some revenue from the first type who buy both units. In this case, the producer surplus is equal to 100 times 10 plus 100 times 20. Let's see why is that. 100 times 10 is the revenue that it gets from this consumer, which only buys 1 unit. So this is from type 2. And 100 times 20 is the fact that it sells at $10 2 units to type 1. And that gives you a total producer surplus of $3,000, which is less than the $3,500. So this cannot be a solution. Now let's look at case 2. Now again, in case 2, the best solution for the monopolist involves having the price 1 as high as possible while having the constraint that this guy buys 2 units. I hope it's easy for you to see that looks like charging 15 and 0. Setting a price 1 of 15 and a price 2 of 0. That makes this consumer indifferent between buying nothing and buying the 2 units and keeps price 1 as high as possible so that the other consumer, so that the type 1 buys, you can get as much surplus as possible from type 1. Now, so this is pi 1 equals 15, price 2 equals 0. What is the producer surplus in this case? is going to be equal to 100 times 15. This is from type 2. Remember, they get nothing from the second unit because it's at 0, plus 100 times 15 from type 1, because they sell still both units, but they only get a revenue for the first one. And again, this is equal to $3,000, which is not as good as the solution in which only the first consumer buys. So what we get is only the first consumer buys, is recruited to buy at the best possible solution, and the monopolist extracts all of the social surplus from that consumer, but none of the social surplus from the second consumer. And although this is not part of the question, notice that the solution is not Pareto optimal. Why is that the case? Because with a zero marginal cost, both consumers should be consuming both of their units, and that is not the case.